think it's kind of a weird thing that it's the internet. You know, what is the internet? A bunch of babblers. That's all it is. Everybody wants to say something. That's what it is. It gives everybody an opportunity. In the past, they didn't have an opportunity to say anything, and they might not have been like me, where they actually wrote the newspaper on a couple of occasions, you know, the letter to the editor. Because some people are a little bit afraid that they don't write that well, or that what they said, they see that, oh, someone will think it sounds stupid, or I'm afraid to do it. I only did it like 3 times myself. I very rarely did any writing in the past, and anything where I would make something public. But see, it's like now, anybody can say what they want. And I think they feel better. You know, I mean, I've been reflecting on this a lot lately, on technology and what does technology... I know I feel a little bit better that I can put a few things down, and I think others do too. You know, so it kind of... even if it's not like they are immediately connecting with everybody that has the same idea, they are putting their idea down on the internet in a category, and if people look for it, they can search for it. And so it gives them kind of power of the right to press, the freedom of the press. You know, so it is and I think that this was part of the intent in the past. I think this was part of the intent of giving the internet to everybody, so that they would kind of have a gripe channel, if they could use it that way. And, you know, that obviously there's various uses of these kinds of things. I think always students have to be educated to the correct uses of technology. I am not someone who doesn't agree that technology should be used in education. I am a person who believes that it should be used with a proper degree of caution in education. As the author a number of years ago of a book called Snake Oil, and where he talked about Silicon Valley and when desktops were first coming out, you know, he raised the questions of technology, like what will this do to the population? Will it kind of rewire their minds, and will it cause them to be different? And it certainly has caused people to be different. And it has, maybe in some sense, for some people, it has made them more mechanistic, you know, more... it has routinized their existence a little bit. You know, before, when they got home from work, there were 4 things that they would do. But now maybe it's like 2. Maybe they'll either get on the internet and they'll get on Facebook, or maybe they'll check out a porn channel, or maybe they'll check, you know, maybe they'll do something on the computer. You know, and in this way, it really has changed the whole population of the earth, wherever computers have penetrated. You know, those things have changed our lives. I think it makes us, one of the things is it makes us a little bit more lazy. Like, it makes us a little more sedentary. You know, sit in front of the computer rather than go out and take a walk, or rather than do some exercise. Although, you know, there's plenty of avenues on the computer where you can watch something and exercise while you're watching it. There's nothing that prevents that. There's a variety of things in uses of technology, and when computers first came out, my friend and I, Dan Gilday, we had many discussions, or Dan, forget that I said his last name. He doesn't mind the fame, but that's not the name he goes by. He actually goes by the name Scary. So, I think he's not really that scary, but but he calls himself Scary, because he loves the Halloween season. So this is his season. Like, so right now, if I went over to his home and I said, Dan, we're doing an experiment, and I'm going to test the levels of serotonin that you have. Now, serotonin is like this brain chemical that you have, and that if you have a lot of it, you'll feel really happy, and you'll feel really confident, and you'll feel really good, and you won't feel depressed. And so it's one of these major chemicals today that in psychiatry, they actually design drugs that affect this level in your mind. And what it does, what serotonin is it's like there are different grades of copper that can be used for wires. And any wires anywhere actually have electrons, these little particles that move through them and communicate electricity. And so what it does when you put serotonin in your mind, it's like you're changing the grade of copper. These brain things called synapses in your mind, they fire like a piston in an automobile motor. So when an automobile motor has a piston which drives through these holes. If you ever see a motor without the covers for the pistons, with those removed, you can see the holes in the engine, and you can see the piston, and the piston in there is driven by the gasoline explosion that occurs via the spark plug. So like the spark plugs of our mind are the little synapses that connect that gap in the spark plug. There's a little gap in the spark plug between that point on the spark plug, and then there's kind of like an L-shaped piece of metal over the top of it. And the gap in there is where the spark jumps from it gets an electrical impulse from the battery, and then the battery forces it to create a spark in that small gap in the plug like that. There's about a small gap about that, it's a very tiny gap. But then you have this little thing called a gapping tool, and you can actually put that in there and you measure to see if you have the right gap. Because if you have too wide of a gap, then the spark will not travel through there, and you won't get the explosion in your piston that makes force the piston to go up and down inside of a motor. And it's kind of a cool process if you learn about it. That's a very simple description, by the way. It's much more complicated today because they have fuel injection systems. And fuel injection is more complicated than in the past. It just squirted some gas in there, and it was like sometimes it had this amount, sometimes it had that amount plus about 1/4 more. And so in the past, engines did not run as well as they do today. But today they have these really complicated circuits called fuel injectors that compute so that you get the exact. So if the gap in your spark plug is actually getting a little bit wider over time because the metal on there, after there's sparks, some of the metal falls off inside the piston chamber. And so the gap of your spark plug actually increases over time. But a fuel injection system car with a computer actually calculates the change in the gap. So then it gives more fuel or less fuel, depending on what's necessary. And it's really cool. I mean, that's why those cars run so well. There's all kinds of complicated things that go into their design. Now, if you can think about that and how complicated that is, like to engineer something like that, imagine how difficult it is to engineer a particle collider, like the Large Hadron Collider. Man, you gotta have ideas. You gotta have ideas about like what angle does the electron have to flow down and then collide with the other electron. Like we've never had, we make a V-shaped motor, but have we ever made a collider that's V-shaped? Like where one of the electrons comes down on one side like that, and then when the positrons come down in a V-shape. All the engineers that design that, they think of things like that. Like how an automobile engine is created, how a particle collider has to be created. Like, is the right way to shoot the particles up? Steve Weinberg is one of my favorite physicists, and he's actually been chosen in the past to help engineer these things. So he sits around and he actually thinks of like, how does the angle of the electron projected upward have to actually meet with the positron that's projected upward in the right way that collision will produce the most information about those particles, But I began talking about synapses in the human mind, and there are these little brain connections, little brain little brain circuits, if you will. And when you put serotonin in the brain from these pills that you take today that are either selective reuptake inhibitors or selective serotonin reuptake inhibitors or serotonin reuptake inhibitors, which just means basically that they slow down the removal of serotonin in the brain, so you have more serotonin in your brain. But I gave an analogy of that, and the analogy of that is if you took a different grade of copper wire and you put a better grade of copper wire in your brain circuitry, then the electrons would flow through there. The electrons and positrons, actually. It's always electrons. It's never just electrons. It's always electrons and positrons. Because Steven Weinberg, I challenge him to isolate one single electron in nature that doesn't have a correlate positron. I bet you can't find one. I bet you look all over God's creation, and he could never isolate one single electron and say that electron does not have a correlate positron. If he can ever find one someday, I would be fascinated by how he would prove that electron, and for any physicist, I put the challenge out there for any physicist, not to stump them or to embarrass them, but just as a thought experiment, a Gedanken. In German, it's called a Gedanken. It's a thought experiment. Could there ever be one isolated electron that didn't have a correlate positron? How would you prove that? You know? How would you prove that every electron does have a correlate? See, the opposite would be difficult to prove too. How would you prove that every electron has a correlate positron? Newton liked to prove these things by saying, if every action has an equal and opposite reaction, there must be an equal amount of negative and positive energy in the cosmos. And so he could make an observation on something like, you go, well, he formulated the third law, which is every action has an equal and opposite reaction. But what was the background to his thinking? Because he was putting modal operators on each of his three laws. He was saying necessarily, if an object is in motion, it will continue in motion forever unless deflected by the motion of another object. You know, and so then the second law, which is force equals mass times acceleration, that would be like if one particle was going one way and then another particle was traveling another way and the two collided, then it would increase the mass, or the force would be increased by the mass, which was increased by the acceleration. And then the third law, every action has an equal and opposite reaction. Necessarily. See, now this is where the important part of science comes in. Newton was saying there's no exceptions to any of these laws. These laws are always true and will never not be true. And that's fascinating. See, when you start thinking about, okay, it's one thing for him to say, well, an object that is undeflected and that is moving in uniform, straight line motion will never cease moving, but it's another thing for him to say that's always true. Like nothing you can do to nature, no explosion in nature, no implosion in nature, no disturbing or moving of a quantum field around, no turning of the coordinates in a quantum field around anywhere could ever disturb that fact. Or nothing could ever change the fact that when you have the positron moving that way and the electron coming toward it, nothing can ever change that the two masses would be increased by colliding with each other. Nothing could change that. And then nothing could change that if one particle acted, another equal and opposite force or particle reacted. Nothing could change that. And that all the sum of those three laws was necessarily the definition of gravity forever. Now that is impressive to me. Not that some guy figured out, like randomly collected a couple of ideas, but how he said it'll be that way forever. Try to change it, he told God.